Then welcome everybody. Glad to have you here in our session. We're going to talk about effective infrastructure testing, and we're going to share some lessons that we learned from the field. And of course, we are not going to do this all by ourselves, so we are two. So, hi, I'm Christian, and I'm focusing on IT automation. I'm working as an engineer and a trainer at SVA, which is a German consulting company. And also I'm a really lazy guy, I would say. That's why I think automation was invented, because I want to have time to see more cat memes or pictures. So whenever there is a quite boring task, I try to automate it so that I have time for other things. And I like tinkering with those machines that are supposed to help you solving problems you wouldn't have had them without them in the first place. I'm using quite a lot of RHEL, Foreman, Uyuni, Ansible, and Terraform. I'm also hosting the German podcast Focus on Linux.
Yeah, my name is Leon. I do have a strong focus on secrets management. Also, I do IT automation. I do love Ansible and Kubernetes, and yeah, often I tend to kind of like over-engineer problems, but mostly I'll find a solution for any problem. I'd say so, but sometimes not. But over-engineering is one of the things I tend to.
I mean, that's why we're getting paid for, right? So,
yeah, right.
Finding solutions for problems that are simpler than the solution in the first place.
Yeah.
Okay. So let's have a look at the agenda. So first of all, we will talk a little bit about why do we need infrastructure testing in the first place. Then we'll show you some of the tools that we have been using in the last couple of months. And lastly, we're going to share 6 lessons that we learned from the field, and we'll also do a proper wrap-up.
Yeah, so can I have thank you. Before we go to the next slide, I gotta ask you, who of you has more than a stronger focus on software development than on doing administrative stuff? Okay, a bunch of you. Good. And who in here has like more stronger focus on administration? Okay. So that's a little bit more. So, yeah, I'm asking because like the next slide is a little bit about testing in general. So from the perspective, from a rather administrative perspective. So you know, a lot of developers test their code. They write unit tests. They have the testing permit and stuff. And we are from a stronger administrative perspective. So we ask ourselves, why shouldn't we also do something with testing? I mean, the developers verify their code with tests, so we should do the same for our infrastructure, shouldn't we?
Right, yeah, definitely. So who of you is already using unit tests for testing your infrastructure? Yeah, quite some people, yeah, it could be more, but it's not completely new to the audience, which is good, I would say.
Yeah, that's good, yeah. So we've brought a few examples, just in case you are not aware why infrastructure testing could be important. So one thing we do is that we set up lab environments. These labs are commonly used for internal workshops with our employees, but we also do them with our customers, and yeah, to ensure that that these complex setups are working in practice. And we don't, will be sweating because of something is not working in the execution of the workshops. We are testing our lab environments, so the maintenance would be not a good thing during a workshop. So there are a few things we are checking, like are the hosts up, is everything installed we need. I got an example here, so this is from a HashiCorp Vault beginner workshop we do. There we have an infrastructure with Ansible running, with a K3s, VS Code server, HR proxy, and we also have 3 additional nodes to install a Vault cluster. And we have to ensure that this environment, which is instantiated multiple times, is working, and for each of those trainees. And that is a thing you have to automate. You can do this manually.
Yeah, it takes way too much time. So I remember last year at another conference I had a training with, I would say, 30 participants, and everybody had 3 VMs, which resulted in nearly 100 VMs, because you also want to have some spare VMs in case somebody crashes their environment and wants to just continue on the new machine. Yeah, and it was 100 VMs, and I think I had something around total tests of 1,300 tests. It would have taken a couple of days to do this manually. 1,300 tests.
Yeah.
It would have taken a couple of days to do this manually.
Okay.
Okay, let's head to the next example that we are going to share, customer environments, of course. So we are working in a consulting company, so quite often it happens that customers book us for setting up their infrastructure, which means that we're dealing with a lot of multiple cloud providers with bare metal machines, with virtual machines in every kind of flavor. It's Proxmox, KVM, VMware, you name it, every vendor that you can think of. Of course, we also have network topology and also services. And this could also be quite a daunting task to check this manually, so we're trying to use unit tests for this, because products are quite the same, but the infrastructure around it is completely different each time. So whenever you did one setup of, let's say, Red Hat Satellite or Carino or you name it, then you know how the application works, but for some customers it's KVM, for some it's maybe Cisco and VMware, and so we know the metrics that is relevant to the application. We can simply test whether the deployment has worked proper as we expected it. So we know the metrics that
Have you ever been in the situation not to being able to pull all RPM packages you need within your customer's environment? I guess that's the pain we all feel, isn't it?
Oh yeah, air-gapped environments. We love it, right? So anybody needs to deal with air-gapped environments? Oh, that's quite a lot. On a scale between 1 and 10, how funny is it dealing with it?
0, probably.
Okay, yeah, so you can relate to that, obviously. Yeah, of course. So using unit tests helps to identify changes or challenges quickly. As we mentioned, things like having no DNS. Of course, it's always DNS or the firewall or SE Linux, as we learned today. And we can also check quite easily to see missing package repositories. So, of course, we'll also test things like whether we have enough CPU bandwidth or memory capacity and so on, and dependency versions of our operating system, just to ensure that before we waste 3 days of troubleshooting things, we can see, okay, this is not going to work because our infrastructure resource is exhausted. So can help.
So as you can see, we're already talking about dynamic information, but also like rather static information like CPU restrictions and stuff. So yeah, just keep that in mind.
Yeah, so speaking of the next example, production hardening. Who of you likes security and hardening and dealing with all those requirements? Who doesn't care about security at all and is team disabling SE Linux? Okay.
I mean, a few.
Less hands that I would have expected. That's nice, because security is important to everybody. So, of course, there are some tools that can assist you with the security and hardening, and we're going to share some of them with you. For example, we have the DevSec hardening framework. For Kubernetes, we have things like kubebench, and Docker also has the Docker bench security utility that we can use. Vendors often offer hardening guidelines that can be automatically tested. So, for example, for HashiCorp Vault, there's the production hardening guide. That is, I think, a set of scripts that you can execute, right?
No, it's more simple. It's just a bunch of things you should do in your environment, so just like documentation, you know.
Okay, so that would be a good candidate to put this in, let's say, Ansible code or the IRC utility that you use in your environment. And we also have things like the OWASP project, so database security cheat sheet that can assist you with dealing with common security procedures. All right, so which tools do we use? We figured out some of the high-level details. Let's get into the proper commands. And the first tool that we're going to share is the check and diff parameter for the Ansible utility. Who ever heard about this? Okay, a lot of people. This is quite nice. So those are basically two different modes that you can leverage with running playbooks. You can use them separately or both together. The check mode only checks which changes would be made. So, but keep in mind that not every module actually supports this. So it could be possible that the person who developed the module didn't implement that feature. That would result in that the module is basically skipped and you wouldn't see what would happen. And it's quite hard to simulate all the changes in infrastructure, because if you have actions that build on each other, let's say, so you install a package and afterwards you roll out the configuration for, let's say, a load balancer, and after that you will spin up a var file, then of course this is not going to help you with troubleshooting, because you didn't actually do any changes. What's quite more important, in my opinion, is the diff parameter that actually lists the changes that were made or would be made in combination with the check mode. But also this isn't supported by every module, but I would say the most core modules have support for it, and makes sense if you, let's say you have a longer playbook or run of multiple roles, and you want to see a summary what actually has changed on the system. So this gives you a good indication of what actually has been changed, and this can assist you with detecting an accidental change you wouldn't have done for the production load balancer. So this can make things short. So both options can be set on task level, or also you can use it on the CLI level, which is what we can see here. So basically, the upper example is an actual playbook where we have just an example code that copies a configuration file, and the playbook using the parameters will show us that the content has changed. So before the file is empty, and afterwards we see we have a new line in the file, which means that this file actually gets created and gets some proper content. And as we can see, we can't use the cat comment on that file because it doesn't exist, because we haven't created it. And as we can see, we can't use the cat comment on that file. Yeah, so the next tool is the assert module. Whoever did this, use this? Okay.
Expected that.
So that's part of the Ansible core, so which means it's included in all the Ansible installations out there. And this module checks if given expressions are true. So we will get a success or an error message. And this can be quite useful in context with Jinja 2 expressions and also Ansible facts. And typical use cases include things like, let's say you want to double check whether a required state is given. So let's assume you deploy a 3-tier application, so you're running database installation, front-end installation, load balancer, you name it, and you want to ensure double checking that the application is working properly before you roll out the changes to your production load balancer. So that would be a great use case, because you have a playbook anywhere where you deploy all those changes, and so afterwards you can simply do another check for that. Or let's say you want to have a pre-check before rolling out actions. So before installing a patch management suite, you want to ensure that you have the proper SUSE Linux serverspec, for example. So we could check this, and afterwards the installation will crash or will succeed. And it's also a good candidate for implementing simple tests in Ansible roles. So we have also 2 examples here. The first being what I just mentioned. We have a pre-check that checks whether we have the expected service pack for SUSE Linux Enterprise Server. And the next one would be we have a command that actually gets logs from a not very good application and registers the output. And of course, we like regular expressions, so we are going to have a look whether we find some of the keywords in that file. And if this is the case, we will see an error message, and if not, we will have a success message. In my honest opinion, this is not very handy for comprehensive infrastructure testing. The syntax is also, it gets some time to get used to it, let's phrase it in that way. Especially dealing with nested Jinja expressions and Ansible logic can be quite daunting. So it's a good tool, but it's also good that we have additional tools for other use cases, I would say.
Yeah, I'd also say Ansible wasn't supposed to solve the problem of infrastructure testing. I mean, someone from the Ansible guys can correct me if that's wrong, but
please go ahead.
Yeah, please do it. Feel free. Yeah, so we've got other tools. Another tool we have is goss. Goss has an imperative and declarative approach, so you can use it either from the command line or just invoke it from the command line with the configuration file. It does get executed locally, so you're running it on the host you want to check. That's what we mean here. It works with Linux, Windows, and macOS. So it's very flexible, but also works for containers. There is a different executable dgoss, which is used to run it within containers, so you can invoke it a little bit easier. You also have that for Docker Compose and Kubernetes. Yeah, we have a bunch of supported resources here, so I'm not going to mention them all, but just so you know that you can check packages, files, ports and stuff, and for each of these things you can test like different parameters. And to give you an example, just a small one, on the right hand side here we have one of the goss files, I'll say. Yeah, there we test if a file exists and contains a specific part of text. Also, we can execute commands, which will basically get executed within the bash environment. We can check the exit status or whatever is printed out on standard out. And also match this again against beautiful regex.
Yay!
We love it. But you can also do HTTP calls, check if packages are installed. So, you know, the stuff which you would expect a testing library for infrastructure to be able to test. I've also brought a little execution example. This one should be hard to read from in the back, but what it is doing basically is, this is taken from the Goss documentation. They do add a test case to validate that the port for SSH is open. Then they run the validate step to check if it's running. They stop the SSHD service, run that thing again, and they will you recognize that the test is not passing anymore. In the end, they'll reactivate the daemon, and which is another cool thing about Goss. It can open an HTTP endpoint where you can fetch the test results. So awesome. If you, for example, have a service within Kubernetes which does not offer health checks, you can inject Goss into that container and present an HTTP API endpoint which you can use for the Kubernetes health check.
And boy, it's fast, below 1 second.
Yeah, it is. It is really fast. So that's one of the big advantages of Goss. Yeah, another tool we will show you is serverspec.
Yeah, serverspec. So who's a big fan of Ruby? Some hands? Oh, great. So serverspec is a plugin for RSpec, which is a Ruby-based testing framework, but serverspec actually is focusing infrastructure tests. So this also has declarative tests. It's also executed locally, but you can also use SSH, WinRM, or also the Docker API if you want to. I'm not sure about Kubernetes, but I think there should be at least some crazy person that are trying to port this to serverspec. So it might also be possible. It's working with Linux, with Windows and macOS. And it has also a bunch of supported resources. So the usual suspects, things like files, users, groups, permissions, gateways, you name it. And we have also an example here. So the first thing is we describe the system that we want to check. So it's a localhost here. We describe a file, so you don't need to be a developer, I would say, to understand roughly what this code is going to do. So it defines a file that should be a file. So in case it's not a file or it's a named pipe, you will get an error. We can also execute commands like an ls on a directory, and if there's some output in the standard error channel, we can react to this as well. We can check cron definitions and also things like the network configuration with the default gateway being a particular value. And of course, we can also check packages, whether they are installed and match a particular version that we want to have on the system. One of my favorite tools is DevSec and Ansible Lockdown. Who heard about that? Okay, some of the participants. So I would say that not only hardening new systems is important. So let's say you create 10 servers today and they are secure today. This doesn't need to be the case in, let's say, 2 months. So we have a lot of CVEs that are taking place even on Linux, so it could be possible that those systems are quite insecure after a couple of weeks. So it's important to also recheck all your existing systems on a regular basis. And depending on your system landscape size, this can also be quite daunting or a high effort, because let's say you have thousands of VMs, then you need to deal with thousands of VMs and need to find a proper way to secure them. And of course, automation can assist you with that. One of the tools is DevSec that audits and hardens your servers. So there are baselines for, let's say, the Linux operating system or the SSH protocol or particular applications such as the Apache web server. So this will help you to see on a scale between 0 and 100 how bad is it. But it might be interesting to know which problems exactly apply to your systems, but it would also be great to have them automatically fixed. And this is where Ansible and Puppet are coming into the picture, because there are content templates for remediation that you can simply use. So there's an Ansible collection, for example, that fixes all the findings in SSH, for example, and you can make use of this. Those baselines are based on various information. So for example, we have the CIS benchmarks, we have NSA hardening guides, and also vendor best practices and guides. They all be merged into those baselines. And those baselines are checked using a tool which is called inspec, which is another RSpec spin-off with a focus on security. So it's basically the same language that you already might know from serverspec or RSpec, but it has various modules for dealing with security information. So maybe let's focus first on the examples here. So we can see in the upper right here, that's an unit test for security that has a proper name and also an impact, because security information can have a higher or a lower impact. So we can assign a number between 1 and 10 here. We have a title and a description, and then of course we have the code that looks quite like serverspec usually looks like. So we have a test that says that we do not want to install the telnet server because it uses unencrypted communication. So we match the package with the telnet DNAME and define that it should not be installed. And running inspec on a system, let's say using SSH, will check whether this test succeeds. So that would be an option.
The only downside is maybe that you, I think, have to pay for inspec to use it commercially, don't you?
So the problem is, inspec used to be a proper open source project, and then it was bought by Chef, as far as I remember. So Chef has the binaries on their website, and by downloading and installing them, you will apply their license, which means it's only for testing on personal purposes. And if you want to use it in the enterprise, of course, you should have a proper subscription. But the source code is available on GitHub anyway, and you can build it on your own, and then another license applies. And of course, it's just shell output. Yeah? If you want to have fancy dashboards for your CISO, there are additional tools like the Chef Enterprise Suite, and there's also this open source tool that does these dashboards, but I can't remember the name. Maybe we will follow up on that later. Yeah, and Ansible Lockdown is basically comparable to DevSec, but it uses goss for testing, so the tool that you just saw a couple of slides ago, and it offers benchmarks and remediation dedicated in a sys or a stick variant. So in case one of those apply to your company, you can use either one or the other.
Just in case you guys, I don't know if you have that use case, but sometimes it is that people are coming to you, hey, like, is my server secure? You say, well, I don't know. But if you want to harden their servers and be a little bit secure, this is like a very good starting point to harden systems, you know.
And I mean, it's easy to apply. So it's a bunch of Ansible collection that you can simply apply and run. Don't do this in production without testing. So do it on a proper testing system. And whenever I roll out a new system, I offer it the customer pre-hardened, and they need to tell me, okay, nice, but my application isn't working, and then I can lower some of them, some of the security standards. Okay, let's focus on the next one, which is testinfra. That's a plugin for PyTest, and as you might guess, it's based on Python, focusing on infrastructure tests. And it's usual for testing the actual states of service. So it's configured. You would usually use tools like Ansible or SaltStack, and then you have Python tests to check the actual state of your system. It's more or less like serverspec, but in Python. And it also supports various connection backends. Of course, we have things like Paramiko, SSH, WinRM, Docker, Podman, LXC, and so on. And we also have fancy Kubernetes and OpenShift stuff. And it can also be used outside of PyTest. So it's also a library that you can include in your own applications if you write Python code. So you can test your application within your application with proper testing framework.
With the right tools, you can also make a binary from it.
Yeah. Yo, dog, I heard you like testing, so we put a test suite in a test suite. And of course, it has optional Nagios compatible output. I don't know whether this is relevant to you guys, but it's possible to have a fancy Nagios or Isinger-based dashboard with your unit tests. So let's show an example. So we have 26 modules and 88 properties for system information. So we have things like environment variables, interfaces, mount points, packages, and so on. And we have nice, beautiful Python code that actually tests our machine. So for example, we have here code that checks whether our firewall is enabled and running, because we shouldn't disable it. We can also check for proper users, whether they exist and have a proper home directory, and the permissions are matching the user. And we can also check particular sockets, whether they are listening on TCP ports. So that's one example. Wrong direction. Yeah, and the benefit of testinfra is that it has a quite easy syntax. The learning curve is quite low, in my opinion. It's way easier to understand than Ruby testing frameworks, but that's my opinion. And the documentation has a lot of good examples. So just open it, copy it, paste it, change some variables, and you're good to go for the starting point, I would say. And those tests can also be parameterized. So if you do a lot of testing and on a lot of different systems and architectures, you can use parameters for that. And it's best practice to split all your tests in multiple files for Lager test suites. So I usually do things like I have a file for generic tests for my infrastructure, I have tests for my application, and I have some smoke tests that are run outside of the machines that I'm going to test. So ensure that it's not only working on localhost, because it always works on localhost, so it's also working from a proper point outside the test network. And I would highly recommend using the Xdis plugin, because it distributes all the tests across multiple CPUs. And I had the problem during another conference where I had those 1,200 tests, and I think it took 1.5 hours to test all the systems. And then a colleague told me, why don't you use Xdis? And I did this, and it only took 5 minutes or so. So great learning to use this in a proper way.
Yeah, and I mean, I think it's like the cool thing about PyTest, testinfra, it just integrates into PyTest. So you can pretty much get everything which is developed for PyTest also with testinfra.
Yeah. So here's another example where we have some parameters. And one learning that I had to learn the hard way just a couple of days ago is that sudo is only supported when your service user that are using with Ansible has the no-pass-wd sudo option set. And of course, my service user didn't have it set, and there is no fine way to prompt for passwords. So those tests are going to fail because you can't supply a sudo password. So it should work with forcing Ansible mode, but it didn't work for me. So I don't know whether.
Did we actually mention that you can invoke testinfra with your Ansible inventory? So you can just basically use your Ansible inventory with testinfra. So the invocation just reads the inventory, and that's basically all you need. If you have your Ansible setup done, testinfra will also work out of the box.
Yeah. So here's a screenshot. So that was the test without Xtest, so 5 minutes. And yeah, with Xtest in a proper notebook with 16 threads, it's just 45 seconds. So I would highly encourage you using that plugin. It has been a real game changer for me. So
yeah, to wrap things up, yeah, we have had goss, serverspec, and testinfra. Goss is the only one which also supports an imperative approach. Goss is based on YAML, serverspec on RSpec or Ruby, testinfra on Python. A downside of Goss is that you can only execute it locally. Serverspec can also be executed via SSH and WinRM, and testinfra also offers Ansible and a bunch of other invocation methods. Concerning the operating systems, there's not much of a difference. Testinfra also supports BSD.
Does it work on Hannah Montana Linux though?
I think so.
That's very important.
That's important.
That's important.
Also, sorry. The scope of goss and serverspec is limited to single servers, while with testinfra, because of the Ansible invocation and other invocation modes, you can pretty much shoot it against a bunch of servers, you know. Yeah, and also we have listed like how many resources are there available, but I wouldn't use that as a strong comparison criterion because they really do vary. I think you can do like the most important stuff with all of these three frameworks. So before I'm going to tell you which one of these is our favorite, who would consider from the things we just told you that goss might be their favorite? No one. Oh, one at least. Oh,
two.
A few,
three.
A bunch of.
Okay, great.
What about serverspec?
Okay, wow, not a single hand raising up. Okay, what about testinfra? Okay, that's a Pythonic group we are hosting here.
We really agree on that, so we both do love testinfra most of these solutions.
Yeah, great.
So, yeah, for the second part of the presentation, we're now going to 6 lessons learned from the practice, from the field, which we picked out for you. So this is like now more of a general approach. Testing in production. Yeah, most of you will probably say, come on, testing in production, don't do that stuff. We actually do that. So the first thing is you have to do that right. There are a few things you need to be aware of. And when it comes to infrastructure, you of course also have to test your production environments. You know?
Or your customers will do it for you.
Yeah, right.
And you don't want them to test this for you.
Right. So one thing you need to keep an eye on is that your tests don't change any state. If they do, in our opinion, the tests aren't proper because tests shouldn't change state. I mean, they can actually generate load. So if you're, for example, running your test against an API or something, they obviously generate load. They will generate probably logs, which could have influence on other users if you have a lot of load. So avoid that. Keep an eye on writing tests that don't do that. How can you do that? A lot of applications do offer health check APIs and monitoring endpoints, so like pretty much every containerized application out there has some sort of PromQL endpoint or a health endpoint when it's running within Kubernetes. Use these things. You can basically just query them and you'll have a pretty proper result. Maybe it's not that it's not some kind of specialized result, but you have some possibilities to figure the special stuff out on other ways. Also, validate your tests in a testing environment before launching it in production. So, sounds a little weird, but yes, we do have testing environments to test our tests. Sounds a little weird, but when you do want to run your tests against production environment, you should test them first against testing environments, so you can be sure that they won't break any stuff.
Yeah, so the next part, state validation. So tests must check the actual state of the system. So it's not enough to verify that your configuration file looks good, because, I mean, we all forgot reloading the systemd, right? So this happened quite often also to me on a regular basis. So it's a good idea to check the actual application, not just the content of your configuration file, to ensure that it's really working and not just the config file. And validate the states of your machines by querying the respective interfaces. So config files are still a source of truth, yeah, so they should be in the right state, but always double check that your application is also working properly. So maybe let's have a look at 2 examples. So the first being here, that's a testinfra test that tests an application, and it simply checks whether the HTTP daemon is enabled and is running. Would you say that this is a good test? Okay, that's great. So a better approach would actually be to check whether on another system, maybe a smoke test system or network, that the host is actually serving requests at the proper socket, and also maybe do an automated curl and have a look at the output. So is there an error message? Is there a string of your application that you have somewhere in the HTML source code? So this is, I would say, the better approach to check that the application is responding as expected. The next lesson would be setting proper priorities. So not everything can be tested with a manual effort. So it is important to set your priorities right and check the very important and most critical things first. Because if you want to have tests for everything, so there are no 100% in IT and in life generally, I would say. So this also applies to your applications and your servers. So maybe ask your teammates what's really important and how can we deal with checking those requirements. Because when everything is a priority, then nothing is a priority, to be honest. So don't work too fine-grained, it will just cost you time, and pick up the low-hanging fruits first. Keep it simple. Yeah? Everybody likes seeing result and success, so maybe start with the easiest tasks.
I don't know, we heard about it. I think we already heard a few times about the KISS principle the last days.
Definitely. Yeah, and as you mentioned, maybe consume your application health checks that can assist you with that. So.
Yeah, the next thing we want to tell you is that Bash is your friend, especially if you have a Bash because you're on a Linux system. Yeah, that might be a little hard to read, but I'll try to explain it for those who can read it. So we got a code snippet here to show why Bash could be your friend. On the left side, we wrote a test which will check if all files it will read all files from a system and will check if they are writable. And the goal of this test is to ensure that you have a specific subset of files that are actually writable. So we do this by just simply prompting a find command into a Bash session, and we check the output of that command. Then we substitute. Then we remove. We then have a list of all the paths which are writable, and then we remove all paths which are allowed to be writable, and then we check if the list of the length is equals 0.
Oh, that's ugly.
Yeah, and the other option, if we wouldn't use Bash, is to do recursion. And I don't think we want to do recursion in Python.
Yeah.
Yeah, we need to do some path joining and stuff. I mean, this is like the recursive code to do the same thing, and but you gotta think. You have to think a lot more about that to get a figure out. So it's probably more easy to just run a find command. That's why Bash can be your friend. Okay.
So next one, test your tests. We all like automated tests, and we should review them regularly and update them and ensure that they are still working as we expect them to do so. Because systems and requirements can change after a couple of weeks or months. That's just normal, and we need to adjust them accordingly so that they are still usable for us. So maybe keep in mind that setting up test environments is a good idea and to simulate test scenarios, and if you're using technologies like Ansible, you can leverage test-driven development with Molecule so that you run a test and then, okay, it's not working, you roll back the proper state before you do your code, and then you can test again. So, and of course also check the documentation of your tests, because it's also important to document your tests, why you created them in the first place and why it's necessary to run them like this. Yeah, and of course we have tools like Renovate. I think you worked with Renovate, so in a nutshell, what it's basically?
Renovate, for those of you who don't know it, is a tool which you can let your repositories, which can scan your repositories, so it will tell you if there are like any new Python packages or like an update for your Helm chart or something. It will just tell you and put a pull request into your repo, so you can just merge that thing and have an update that way. It also will have some kind of dashboard to check which can be what can be updated, which versions, which packages will be affected. So it's a pretty handy tool to to manage your updates.
Okay, so in a nutshell, who never heard about Ansible Molecule? Okay, some hands. So it's basically a framework that assists you with developing Ansible content, so things like collections, but also roles or playbooks. And it does so by automating all that boring testing workflow steps. So things like spinning up a container or virtual machine on your, let's say, development host, linting your code that it's looking good and also working good and follows all the best practices out there. It can run your content, which is called converging your test machines that you just spun up a couple of seconds ago, and you can test those machines that are only running temporarily on your system using a verifier. So things like the Ansible storage module or also the testinfra that we just showed you a couple of slides ago. And afterwards, it can simply destroy those containers and VMs. So the next time you're going to test the code, you will have a proper new machine that hasn't been converged before, and it's in a worst scenario state, so that you can really ensure that your code is working properly, even if all those requirements aren't met. It's a Python package. And there's this Molecule plugins Python package that extends this functionality. So it has support for containers like Docker, Podman. It also supports Vagrant, OpenStack, and so on. And the example that you can see here on the right is, so that's the YAML configuration file for Molecule, where we define that we want to download Ansible dependencies from the Galaxy. We'll use the Vagrant driver to spin up local VMs on our hosts. We do proper linting with YAML lint, Ansible lint, and Flake 8. And we're going to spin up an OpenSUSE Leap 15.5 machine with 4 CPUs, 16 gigs of memory, and we're running Ansible code, and we are executing our tests with testinfra, and Molecule lists can list that those machines have been created on our machine. We have run the code and tested it, so it assists you with the whole development stream that's taking place.
Yeah, that's kind of how you ensure your test can be run in production too.
Definitely.
Yeah. The very last lesson we have is that documentation is essential. So if you don't know, if you can't read anywhere what is tested, you don't know what you still need to test, you know. Therefore we'd suggest to use tools like Doxygen or Swings to generate documentation also from a code. That's very handy. You can just parse the doc strings from your tests and generate documentation out of it, so you don't have to do this like all by hand. Yeah, another thing which you can do is you can generate test protocols. For testinfra, for example, you can simply export a JUnit XML, which you then can further use within other tools to show which test runs successfully, which did fail. Yeah, an example for that is this one.
I like that. It's a green pipeline. I always like green pipelines.
Lovely, isn't it? On the right side, we see a screenshot from GitLab where we that execute a pipeline. Within this pipeline, PyTest is running together with testinfra, and the test results are exported as a JUnit XML, which we then import again into GitLab. You can do this in the GitLab pipeline configuration. If you can read it right now, you will get the slides afterwards. Then you can see how you configure it on yourself. Yeah, but as a result, you get these nice reports, which also can serve as part of your documentation and can visualize what you tested and how good your test performed. A thing which is maybe missing would be some kind of coverage report, but you cannot really generate that because you will get, I mean, PyTest can generate a coverage report, but it will only show you the coverage of the Python code you wrote, not of, like, you would want a coverage of how much of your infrastructure you tested, maybe. That's like not the proper metric you would use here.
Right, okay, well then, let's do a wrap up. So I think we've figured out that testing is relevant for both code and infrastructure. For example, we mentioned the lab and customer environments. Not only functionality is important, but also security should be tested. It applies to all of us, I would say. And various tools can assist you with efficient testing. So we have special tools per use case, so it depends on your use case. You learned just about some of them. I think there are even more out there, so you can test all the test tools whole day if you want to. And of course also ensure checking an actual high-level state. So do smoke tests, check your application from outside your systems to ensure that it's working properly. And yeah, less is more. So try to focus on the important things. Don't over-engineer your stuff, even though I know it's interesting and you can learn a lot. It's not worth it every time.
Most of the time it's good to also just start. Just do that. Just write one small test. It doesn't have to be anything special. If you like do the first step, the next steps will follow automatically.
Yeah, and of course documentation is key. So who likes writing documentation here? Okay, at least some hands. So I know it can be a kind of boring task, but it's important to everybody. So
the fun thing is, I guess from the first keynotes we had yesterday, I guess the same question was offered, and I think there haven't been any one who said that he or she likes documentation.
Yeah.
But now we have some guys. Maybe there has been some change.
Definitely. So thanks for listening. So you can get the slides either by scanning the QR code, but you can also check out the conference system. So we uploaded the PDFs there. So you can grab your copy and check out all the tools. And in case you have any questions and want to get in touch with us, of course, here are our contact details. So go ahead, write us a mail. Are you on Mastodon by any chance?
Not yet.
Not yet? Okay, we should change that. I'm stdell@chaos.social, so just ping me or talk to me in the conference. And yeah, so thanks a lot for listening.